Thank you so much for attending this session today. I'm a backend developer, but today I'll be a storyteller. Come along with me to discover a journey full of artificial intelligence, testing, challenges, and who knows, maybe even love, to find the answer to this question. Will AI free us from doing unit tests without any human interaction? But let me introduce myself briefly. My name is Isabel. I come from Barcelona, Spain. I'm a senior backend developer, and I've been working for more than 10 years now. Also, since this year, I'm part of JetBrains Community Contributor Program. Yay! I'm a former testing teacher in a university in Barcelona called La Salle, and also I'm an instructor in 2 online coding courses in a Spanish platform. But let's begin. So actually, I started thinking about this talk on May this year when I was traveling with some friends. They are all QAs, and I'm the only backend. So I was explaining to them that part of my daily job, a critical part of my job, is actually to ensure that the code that I develop, it's working and it can go to production. So I do that through testing. And one of my friends came to me and said, "Why are you doing tests instead of developing other features? It's a waste of your time." And at the beginning, I was a bit shocked. I was like, what? But then I realized that I was living in an echo chamber because all the people that surround me, all my backend colleagues, understand and value deeply testing. So it was like the first time in a long time that someone said, "What? Why are you doing that?" But this is just an anecdote. I didn't give it much thought about it, and I keep going with my life. And after some time, I came across this other article explaining tools that you can use to generate automatically, using artificial intelligence, unit tests. And the first paragraph said, "Software development is a creative endeavor, but it can fill with tedious tasks. Most mundane of all is writing unit tests, bits of code to verify that software components work as intended." As a TDD practitioner, I feel devastated when I read it. I was like, what? What's happening right now? But when I calm myself and the storm passes, I say, maybe I'm missing something here. And I decided to look at things from a different perspective and try to learn as much as possible from creating tests using artificial intelligence. But before we go there, allow me to talk you briefly about a couple of things related with testing that will be really important, really significant once we review the responses that we obtain from the tool. The first one is, what's the unit? Maybe it surprise you or maybe not, but the answer to the question is actually it depends. Okay? For example, it depends on the school of TDD that you are following. The most known, the most widespread is London School. We have 2 schools, okay? The first one is London School. For them, the unit is a class and they focus on interaction. This book here, Growing Object-Oriented Software Guided by Tests, is the most significant book for this school. And what they propose is that we create test double or mocks for all the collaborators in a class, and then we write our tests. But we have another approach, Chicago School. Chicago School says that the unit is a small collection of pieces that together delivers the behavior we want. The most representative book for this school is Test-Driven Development by Example, written by Ken Beck, which is also the most known figure of this school. And once we know what's the unit, let's see what are good unit tests. This is something that we will really need once we review the code. So we have one approach called FIRST, which is actually an acronym proposed by Brett Schuchert and Tim Ottinger around 2007. And you can find more information about this acronym in Clean Code written by Ken Beck. And FIRST stands for fast, which means our tests should be fast enough that nobody hesitates to execute them on every single change. Isolated, because the reason for failure should be just one, completely isolated. Our tests should be repeatable, which means that the result of one test should be always the same independently if we execute them once, twice, 100 times inside a test suite alone, always the same outcome. Tests should also be self-validating. No need of human interaction to understand if this test is passing or not. And to finish, tests should be timely. Timely for the authors means that tests should be written at the right time. And at the right time is just before the code that makes the test pass, just before we develop the implementation. This can sound a bit hard, okay, maybe a bit extreme, but they defend their point of view, explaining what they think that testing, once you have the implementation done, provides. So this kind of testing provides less value at a higher cost. Eventually, developers feel guilty about how much time they are spending polishing code that is finished and can be easily convinced to abandon the effort. Just a minute, I'm going to drink water, sorry. But hang with me, we are almost there, because to finish, to understand what are good unit tests, I'm going to present you test desiderata. Test desiderata is a compound of 12 terms, defined by Ken Beck also, that could tell us how we can identify good unit tests. I'm not going to talk about the 12 terms because, there will be a lot of time. But I'm going to try and define only the ones that will be relevant for our examples later. So first we have behavior, structure insensitive, readable, easy to write, fast, and deterministic. So structure insensitive means that our tests should not depend on the implementation code that they are covering. And this is important because if we refactor our code but we don't change the behavior, our test should be passing. Also, we have the last one, deterministic, which means that the outcome of a test should always be the same. And it's really easy to create undeterministic tests if, for example, we use the current date time in a test. This test is undeterministic because every time that we execute them, this date is going to be completely different. And also we have automated, isolated, composable, specific, predict production, and inspired. I'm only going to talk about the three last ones. So specific means that the reason to fail for a test should be extremely clear, and we should not need to debug the code in order to understand what's failing. Tests should predict production. We, of course, every one of us understand that production is a completely different environment from any other environment. But we should try to bring this gap between our test and production closer every time. That should be our goal. We can do that, for example, creating a test every time we find a bug in production. And also tests should be inspiring. They should inspire us confidence. We should feel confident enough if our test suite is passing to go to production. And this has a really cool effect because if you feel safe when you execute your test suite, you feel more empowered to try new things. Because if the tests are passing, everything is fine. Now that we have reviewed a bit the theory, let's face the challenge, okay? And I'm going to show you some code that is available in this GitHub repository. Just a minute. Yeah. Okay, so before we go to the code, just a bit of context. We are going to create a new feature inside a Bets application, and this new feature consists on creating reminders. Everything will be explained in a description markdown file, and we use this description markdown file as context for the third example that I'm going to show you. But it is something that I will remind you about. Also, what I'm going to do is to create tests for an existing code, because what I want to simulate is a situation in which someone has finished their work, has finished the implementation of a feature, and decide to ask an artificial intelligence tool to provide the unit test. Let's see the code. Okay, this is good enough. Do you see it? Yeah? Okay, perfect. Thank you. So, what we are doing is that we are building a bet application, and we want to add a new feature. A bet should be able to create a reminder for a bet. To create a reminder for a bet, we need the bet's email, the time to add to the current date, it could be days or months, the weekday when it should take place the reminder, the name of the pet, the birthday of the pet, the email of the owner. Oh, this is weird. Sorry. The email of the owner, the type of the reminder. We have 4 types: treat for parasites, follow-up, check-up, and screening, and a message. We need to know that the reminder should be visible for both the owner and the vet. Also, take into account that the vet will see the reminder order depending on the type of the reminder and the age of the pet. And the result reminder should be a date in the future, which is correct and should correspond. I don't know if something, yeah, it's okay. And should correspond with the weekday indicated. And now we are seeing the code. We are going to see the code that we are going to test. This is written in Kotlin with Spring Boot framework, but I try to explain everything in case you are not familiar with the technologies. So, we have here a controller which contains an endpoint, a post endpoint, /API/reminders, and this endpoint receives a body, which contains these fields: pet email, the time offset, which is an amount and a unit, the weekday, the pet name, pet birthday, owner email, reminder type, and a message. When we receive the request, we validate it. The validation is only checking that the pet birthday is an actual date. Please don't judge me. I use also artificial intelligence to generate the code, and this is the best I can get. But yeah, we are checking that the pet birthday is an actual date, and if that's not the case, we will throw a specific exception called invalid pet birthday exception. But if everything goes fine, we will continue and we will call our reminder service with all the requests. Here, what we are going to do is to create a reminder, calculate the date in which the reminder should take place, save the reminder, and return it. Let's see a bit. Let's return it again. Oh. Let's see a bit of the calculator. So what this function does actually is to calculate based on the current date. It will add, depending if we are sending days or months, the specific amount of time. And then it will adjust the resulting, oh my God. It will adjust the resulting date to be on the requested weekday and return the date. And once we have seen all of these three components that are the most important ones, let's go with the first attempt. So, to obtain the first attempt, I actually have a long conversation with JetBrains AI assistant and ask the assistant to read the code inside the package and make some tweaks because there was something that was not actually completely right. But once the solution was correct, I used this prompt. Okay, I need unit tests for the feature of create a reminder. Could you do that for me? And this is what it gave me. Oh my God. This test. Well, this test class with 4 tests, actually. I'm going to close this one to see them better. So what we have seen, this is the first test that we can find. It's covering the happy path for the feature. And the first thing that we are seeing is that the reminder is actually a test double, it's mock. So if we only have tests for this class and the collaborators are mock, this is not enough. But let's continue. We have here the request. We are defining the reminder. We are preparing the expected response. Now we define the behavior of the reminder service. We execute the call and save the response. And what we do in the following asserts are ensuring that the response is a 200, which is correct. Maybe it's a bit weird for a post endpoint, but it's what it's implemented. We are also ensuring that the expected response that we have defined here is actually the one that we receive, the body that the one we receive. And to finish, we are verifying that the function was called, that the reminder service function was called with the specific request we use in line 55. This is actually not really needed, this last verify, because we are just ensuring this behavior in line 54, but it's just coupling us to the implementation. So this is not giving a lot of information, and it's not been very useful. Well, let's see the errors. Maybe this is better. So the first one, we have the mock again, the reminder request, and we are indicating that the reminder service is throwing this exception. This is actually wrong because this service is not doing that. This exception is thrown by the same controller, but okay, whatever. What we are doing right here is that we are checking the response code returned by it. But this is not the case for the next test. The next tests are also covering failure. And they are pretty similar to the previous one. Here we are saying that the reminder service is thrown this illegal argument exception, which could be something that could happen. But this is not correct, okay? Here we are checking that the controller is throwing again the exception that is receiving, but actually Spring Boot doesn't work that way, because if something, well, not Spring Boot, not our code. We are catching this exception here, and we are returning a response, so this is not going to work ever. And we are checking that the exception message is the specific one. And the following test is exactly the same, just changing the request, which is not affecting the behavior. So yeah, those two tests are not giving us a lot of information. I don't feel really secure with those tests there, but it's okay. Let's review what we have found on this first attempt. So at the beginning, I had a long conversation until tests generated by the JetBrains assistant was good enough to try them. There was 4 tests generated, but the test didn't pass. They were also coupled to implementation. We also have there some current date time, which would make them not deterministic. And there were tests for failure, but most of them were just checking that an exception was thrown, which is not the behavior that we were having. So yeah, they were not really good. Let's try again. Okay, let's try again. This time, I give the code as a context for the assistant, but I use a more generic prompt. Okay, I use this one. I would like to have some unit test suggestions. No Spring Boot test, please. This is really open, it's not specific at all. I'm just asking for suggestions, so I'm not expecting really good things. But I'm specifying that I don't want a Spring Boot test in this case. Why? Because I tried several times, I did several attempts before I picked 3 of them, and this behavior was something that I have seen. Maybe this time is better, I don't know. So for this occasion, the assistant gave me 2 test classes, which is, I mean, it's better than the previous one. But those test classes are only covering the happy path. So yeah, something is missing here. It changed a bit the style of the test, but it does mostly the same. It's creating the request. Here we are using the current date time, so this test is not deterministic. But the weird thing happens here. So, this is checking that a created status is actually the response status, which is not correct. The controller status returned is an OK at 200, but the strangest thing happened here with this asset. So what is happening is that the assistant is deserializing an object and greeting it as a string, and this object exactly, the reminder that I have defined it here, and then is doing the same with the response body, and is comparing those 2 strings. But those strings will never be the same because the reminder response and the response body are completely different types, are completely different classes. So this is not really, this is not going to work ever. Let's try with the reminder service maybe this time. Well, no, again. This doesn't compile. This is only covering the happy path also. Apart from the things that I was mentioning previously, this doesn't compile. And it's completely making up functions and return types. This is actually not what is working or what the codes have. And with the assets, well, it doesn't make it better because it's checking that something is not null and then checking that that something is equals to a specific reminder. This one is not really needed, but yeah. And this verify here is just coupling our test to the implementation, because we are not checking at all the information inside the reminder that we are saving. So, I mean, this is not safety. We can change the code inside and this will keep passing if it was compiling, but it doesn't compile. So let's see the review for the second attempt, which sadly was not much better than the first one. This time we passed the code as context also, but the prompt was not specific. There were 2 tests generated, but the test didn't pass, and one of them not even compiled. Those tests were coupled to implementation. They were not deterministic because we are seeing the current date time again. And there were no tests for failures. Also, we were missing critical tests for one critical collaborator, which is the calculator. We have one last attempt, I promise. No more attempts. And for this last attempt, I use also the description markdown as context. So I pass the description markdown as context, I pass the code as context, and I used this prompt. Okay, now I'll need all the necessary unit tests to cover create a reminder behavior. And it was a bit better. Because this time we have 3 test classes. But we are just covering the happy path and one error. And this does neither class compile, I think, if I remember correctly. So we have here a class that doesn't exist, a completely made up return type which have a completely made up response, because reminder response doesn't contain those fields. We also execute the function, and yeah, this time we are checking against the correct response code, but the body is not correct at all. And we are again ensuring that this function is called exactly once, but without checking any kind of argument, so not really a lot of information. The error that we are covering has more or less the same, but again, we are checking that the function is throwing, the controller is throwing the function that was received, which is not correct because the code is catching it. And we have this verify here, which if we expect to have this exception somewhere, this is not really something that we will need, but it's okay. If we go to see the reminder service, we have one error covered, and the happy path again, but nothing compiles. This is less readable than the previous one, because we have defined all the variables here, and the request is defined here, which is also not correct. This function is completely made up. And the asserts are weird this time already also. We are checking that the reminder is not null, yeah? But we are just ensuring a couple of the fields of this reminder. So not the whole object. And we are using again this function that doesn't exist. And to finish, we have our first test for the reminder datetime calculator, which is not compiling also. This is not the function, and this is not the signature that we will need, but okay, we have something. Let's be optimistic. Maybe the assets are great. No. The first one is ensuring that the result date is on the same date of the week that we have indicated. And the second one is just checking that the function happens on the date happens on the feature. So we are not really ensuring if the calculation of the notification date is correct. With those 3 tests, let's have a quick summary of this third attempt. This time we have a description markdown and code as context, but again the test didn't pass, they didn't compile at all. We were covering just one error and the happy path, of course. Those tests were coupled to the implementation. And this time we have tests for all the classes, which is like the best option of all of the ones that we have already. So with that said, what do you think? Will AI free us from doing unit tests? Before giving you my answer, I would like to remind or bring up this slide, which is from 1979, from IBM. Supposedly, Twitter said that. It's my source of truth, so now I need to check for a new one. Says that a computer can never be held accountable. Therefore, a computer must never make a management decision. I would like to focus on the first phrase. A computer can never be held accountable. Okay. Thinking about that, if we deploy something to production and it fails, we cannot say the AI made the test and I felt sure when I see them. That's not good enough. I mean, nobody's going to say, yeah, okay. That's a really great way to work. So my answer will be no. AI will not free us from doing unit tests without any human interaction, because only people can be held accountable. You need to know what you are testing and how to do it to be sure that something is good enough to go to production. But I don't really want to finish in a negative note, or that you go away and think that I'm a hater of the AI, because I am not. I truly believe that AI is a really powerful tool that can help us a lot writing tests. But I mean, a huge amount of help can come from this tool. That's why I would like to finish talking about a few ways in which the AI will actually help us writing unit tests. And the first one is generating examples in a different situations, okay? If we have a legacy code, when we have classes with a lot of attributes and really complex interdependencies, and it's a nightmare to create examples for these classes, we can ask the AI tool that you decide, Copilot, JetBrains AI Assistant, ChatGPT, whatever, and it will give you a perfect example that you can use in your test. But also, if you work creating endpoints, APIs, you can ask the AI to give you examples of the features that you want to implement. And to finish, I would like to tell you something that actually happened to me last week. So one of my colleagues had some problems creating a unit test for a Micronaut application. I have no experience with Micronaut, no experience at all, and my colleague more or less the same. So we were like checking ways of doing it, we didn't find anything, but at some point we arrived to an example that was exactly what we wanted to do, but in a really old Micronaut version. So we were trying to do by ourselves, okay, maybe I think you can substitute this for this one, but it was not working. We passed this example to ChatGPT and asked for an upgrade for the Micronaut version till the one that we needed, the 3.8, I think it was. And well, it didn't work at first, but we were able to achieve a test that was working. So that's a really great way to use AI to help us creating unit tests. And with that says, this is the end. I hope you enjoyed this talk. Thank you so much for attending. If you have any question or you want to mention something, I'm available, or we can talk later.